So this is the solution of the practice quiz. I'm going to solve it, and I'm going to show you also how to show your work, because it's very important when you submit your quiz. I need your name, and also I need you to show your work to get credit for that question. Okay, it's very important to show your work, and this is what you need to do. So I'm going to start with number 1. So number 1, it says, determine if the sets are finite or infinite. If they're finite, state their cardinality. So this is the set. So the set of odd integers between 11 and 20, and the odd integers, inclusive. Inclusive means you include 10 and you include 20, okay? So what are the integers? I'm going to write the set A, include the numbers. Odd. Is 10 odd number?
No.
No. So what is the next odd number?
11.
11. So I'm going to start 11. What is the next one?
13.
13, 15, 17, 19. What is the next one? 21. But 21 is bigger than 20, right? You have to stop from 10 to 20. So that's it, right? This is my set. The set of odd integers between 10 and 20 is this set, right? We list the set. So what are the numbers? How many numbers there are?
5.
5. So you're going to write the cardinality of A. You can put N of A, or you can put absolute value of A. Doesn't matter which one. Is going to be 5, because these are 5 numbers. So also they're asking, is it finite or infinite?
It'd be finite.
It's a finite. You're going to write it. It's a finite set. So these are the answers you need to include there. Okay? You have to list the set. You have to write the cardinality. You have to write what type of set it is. And that's all. Any questions on this? No? Okay. Then you're going to go to number 2. Number 2 says, express the following sets in roster form. So that means the one I just write it down, roster form. And state the cardinality of the set. And this is the set of letters in the word Mississippi. So we're going to list all the letters, right? So what are the letters? Without repeating. So I'm going to write the set A, include the letters capital M, capital A, I, capital S. Now S is repeating, so I'm not going to list it again. I is also included, S included, I. P is the next one. Repeating. And that's it, right? So these are all the letters without repeating of the word Mississippi. So these are the letters you're going to use to write the word Mississippi. How many there are? Cardinality of the set A is what?
4.
4. That's it. Now, that's all what you want to do. They want to express in the roster form and state the cardinality. That's it. Now, I want to make a note here. It's important that the letter capital M is different. It's a different letter than the letter M. So these are 2 different letters. M, capital, is different than lowercase m. So that means if I have in the word lowercase m, I have to include it in the set. Make sense? You got it? Okay. Then you're going to go to number 3. Number 3 says, for the following problems, determine, actually it's only one problem. Determine if the given sets are equal, equivalent, both, or neither. So when 2 sets are equal, if they have the same type of elements, right? The same element, the same number of elements. Equivalent is when they have the same cardinality. Both, it's technically when they equal, they're both. Or neither, when it's Neither, right? When they're not the same and all that. So let's look at the set A. The set A has cardinality. What is the cardinality of set A?
4.
4. Set B has cardinality 1, 2, 3, right? So because they have different cardinality, that means they're not equivalent, right?
Correct.
I'm trying to equivalent. Okay, they're not equal because they have different elements. So they're not equivalent. Obviously, they're not equal. So if they're not equivalent, if they're not equal, what is it?
Neither.
Neither. So that's your answer. The answer is neither. Everybody understand that? Let me kind of put the box the answers. Actually, all of this is the answer, so I'm going to leave it for now. Okay, any questions? The next one is for the following problem, determine the cardinality of the power set. So what is the cardinality of the power set? Remember 2 with exponent n? So that's the form you're going to use, 2 to the n. That's the cardinality of the power set. That's the keyword here. So the set A is blue, green, red, yellow, black, white, pink, purple, right? Purple, pink, doesn't matter. So first I need to find, let me move that down. So first I need to find what is the cardinality of, N is the cardinality of set A. What is it? How many colors we have? 8, right?
8.
So there are 8 different colors. So the cardinality of the set A is 8. Okay? Now, what is the cardinality of the power set? So we're going to put P of A, that's the notation. It's going to be 2 to the n, it's going to be 2 to the power 8. And what is that? I have my symbol up here. 2 to the power 8 is 256. Okay? Okay? And that's my answer. The cardinality of the power set is 256. And I told you if it's a big number, you don't need to list them all, right? That's it. Any questions? So far, so good?
Yep.
Okay. Okay. Next one is number 5, which is number 24 on your, from the book. And we're gonna check this, determine if the following equalities are true or false. So we have to check if A complementary union with the union set is equal to B complementary union with the universal set. So you have to check that. How you check it? You're going to do the Venn diagram for the left side. I'm going to say, let's say the blue side. And also I'm going to do the Venn diagram for the red side. And if I shade the same, if they have the same shaded area, then it's true. If they're not the same, it's going to be false. So let's check that out. So first I'm going to do the first one, the blue one. So I have the picture, I have the universal set. Because I have A and B, I'm gonna, so this is my universal. And then I have A and B, the two sets. Now, what I'm going to do first, I'm going to shade AC. What is AC? Complementary of C, which means outside, complementary of A, which means outside of A. So that shades everything outside of A, right? Outside of the circle A. So this, the yellow shaded a little sun shape it's the area outside of the circle A. So everything outside of this circle, outside. Then I need to find the union, the common part with the set U. Union means all together, right? So this yellow plus everything in the universal is gonna cover pretty much everything inside this box, right? Yes?
Yes.
So the shaded area for the blue part of my equality equation is shading the whole box. Then you're going to do the same with the red side of this equation or equality. So you have again the universal set. We have set A, we have set B. And you're going to start shading. First, you're going to shade BC. BC is outside of B. So this is B. And you're going to shade everything out of B. Okay, everything out. And then you're going to find the union means also or the universal. So again, I'm going to shade everything in this little box. So are they the same shaded area?
Yes. Yes.
Yes, they're equals, right? Okay, so the statement is true. Yes?
Yes.
So the answer is true. And I'm just going to put it like this. So that's my answer, true. Okay? Any questions? Now, when you do your quiz, you can do this. You can draw this in a paper.
Yeah. Can I use paper and actually just scan it?
Yes, yes,
To use a
that's
okay.
what I'm saying. Yes, that's what I'm saying. So you can draw these Venn diagrams in a paper. You can scan it with your phone. With notes, go to notes. There is a scan. Click on the scan the paper, send it to your email, and then you can use, so when you go here, when you open your file, it's going to look something like this. You're going to go to Snipping Tool, and you can, I'll show you. It's coming, okay. Oops, there is a Snipping Tool. When you click at New, you can just get whatever you need. Let's say I need only this. And then when you go to your Word file, you can copy and paste. Control V is going to paste it. So let's say I want to go to a new. I'm just going to show you. Let's say this is my quiz, a new file. And I'm doing my quiz here, and I'm going to Control V is going to put it here. So the graph, whatever you draw on paper is going to be here. You can make it smaller or adjust it or do whatever you want to do with it. Okay? Got it? So that could be also another option, but make sure your file should be in Word file. Okay, then let's do another one. We have another example like that, which is 21 in your actual book, from the book. So don't look at this 21, it's from the book 21, number 21. And this is what you have to check also. We have to check if it's true or false. So again, I'm going to have blue side of my equation, and also I'm going to use the red one or pink one, whatever the color is. So let's see what you have in the blue side. We have so we have A union complementary of B, and all of these complementary. So let's start with, here we have to do this first. Then after that, I'm going to do the inside of the parentheses. And then after that, I'm going to do the complementary outside. So we're going to do three things here. And we're going to start with, let's start with drawing the Venn diagram. So we have the universal and B again. So this is set A, this is set B, and this is my universal set. Now I'm going to do BC first, which is complementary of B. Complementary of B was averaging outside of B. Yes?
Yes.
Okay. And then I'm going to do union with A. So union with A pretty much, let me just do different color of A. So this is A. So this is A. And A union with BC is pretty much everywhere I shaded, right? So everywhere I shaded was outside of this little area here, right? Outside of this. Yes?
Yes.
Okay. Everything outside of this area is shaded. And that's where the A union with BC is. Okay? And then from here, we have to find the complement. The complement of this is going to be opposite, right? So opposite of the outside area, it's inside area, right? So the averaging, the whole problem is going to be averaging inside of this little area. That's my answer. Okay? Everybody understand that? So the complementary is opposite. If the A is inside, A complementary is outside. If the area is outside, the complementary is inside, opposite. Okay? So everybody understand that this green shaded area is my answer, right? So the area for the right side is this shaded area. Okay? Now let's look at the other one. Let's look at the pink one. Pink side, the other side. So I'm gonna start again with the universal set. We have set A, we have set B. Let's make this better. Set A, set B. And then we have to start with, we have to do A complementary first. And then you're gonna find where it's intercepting the B. So the common area between AC and B is gonna be my answer. So let's start with A complementary. So complementary of A is outside of A, right? We're going to shade everything outside of A. Okay? So everything outside of A is AC. Okay? Now we need to find where they intercept with B. And this is where B is. So B is over here. Right? This is B. So what is the common part between the yellow and the red? So it looks like it's the same, this area, right? Everybody see that? So this is going to be the area where outside of A and B cross each other, right? I'm using the same shading, the same color. So everybody see that? Are they the same?
Yes, actually. But
They are
I
fully
would,
the same.
but
Yes?
the areas are the same.
Yes. That's what you need to do, the areas. So it's going to be true or false.
Ooh.
They're the same area. This area green and this area green is the same. So they're equals.
So the area to the
You're looking for the final area. So after you put everything shaded and whatever it's in common, You shade it, and you see if they're the same shaded area. Make sense? Okay? So then we're going to go to the next one, which says for the following sets of Venn diagrams. Actually, let's put it down here. So we have for this Venn diagram, or I can make it, you know what, let's do it here. For this Venn diagram, we have only one of those. Use set notation to describe the shaded area using intersection. So these are the symbols. Oops. You know what, I'm gonna just make this a little, I took this from the book again, it's number 30. I'm just gonna make it smaller, it's too big, right? Okay, there you go. Okay, so this is number 30 from your book. I mean, you have the answer there also, but so let me show you how to do this one. So here we have to use the symbols for intersection, which is this symbol here. Union is this symbol. Complementation is the little C, if you need those symbols, 3 symbols. So these are like operation between sets, intersection, unions, and complement, whatever you need, to express this shaded area. And here the answers could be different because obviously, if you look at the examples we just did, the same shaded area here could be expressed in this form or in this form, right? So the answer could be different, but when you apply that, it should be the same shaded area. So here, looking at this shaded area, what you have, the shaded area is obviously, how you're going to describe this shaded area. It's part of A, but you have to take off this part and this part. So what's going to be this? How are you going to express this, like with union and intersection and complementation? How? Any ideas? So how you can describe this? Okay, it's obviously A and something else, right? So it's going to be, so let me just make it here. Okay, so it's going to be obviously A. One of the option is A. Intersection with something else, right? So how are you going to express this part here? This part here, how are you going to describe it? And actually everything outside. How are you going to describe this? Outside of BC. Because when you get the intersection, the common part between the outside and the A, you're going to get exactly this shaded area.
Not sure.
Huh? I mean, it's going to be the outside of B and outside of C, right?
Right.
So you can write BC and B CC, right? Outside of B, outside of C. And it's going to be, because or means both of those. And that's it. You can just put parentheses like this because you're doing this inside first. So you're going to do this first. You're going to shade the yellow one first. And this in parentheses, it's exactly shading the yellow part, the one I put here, the yellow one, the yellow shaded area. It's outside of B and outside of C, right? Everything out. So everything out, whatever it's in common with the A, is going to be exactly the shaded area here. Okay? And that's one of the options. This is one of the answers. You can use this one. Okay? Everybody understand this?
Yes. Yeah.
Got it? Okay. Okay, so let's go ahead and do the next one, which is number 7. And number 7 should be this one, which is also from your book. Or I can just put hold on. Okay, that's number 7. And let's go ahead and read this. This is number 2 from the book. In a small Midwestern town, a survey. So this is a survey question, something like we did in the on the slides. Okay. So here we have a survey conducted of the 125 residents. So this is the total number in the neighborhood. That's the total number of people. So that's the number of universal is going to be 125, right? It was found that 88 of the residents own a car, 59 own a truck, and 21 own no vehicle at all. Okay? Of those surveyed, how many own both? So that's the first question. Both. And how many own only truck and only car? So I have 3 things to find here. And again, you're going to start with the Venn diagram because it's easier that way, right? So you're going to have the total number is 125 people, the same way with the chocolate or lollipop in the slides. We have, these are the people who own a car, and these are the people who own a truck. And let's see what we have. And they have somebody who owns truck and car, right? Both. Okay, so we have 125 is the universal. And we have the number of residents who own a car. So number of car owners is 88. Number of truck owners is 59. And 21 own no cars at all. So this is the 21 outside. They have no vehicle at all. Okay? So 21 is the number of outside of the car and truck owners. Okay, none at all. So how many own both? So this is the question. So you need to find X here between both of those, right? So that's the first question. What is X? How are you going to find this? Okay, I know. Can I find how many own a car or truck?
Yes.
How many?
Well, you know that 88 have a car and 59 have trucks. So a car or truck.
It's not exactly like that because some of those 88 they have both. Some of those 59 they have both also. So it's not quite like that. But you can use the formula you have from the slides. The number of car or truck is the number of cars plus the number of trucks minus the common part, right? Both. So this is or car and truck. So this is the symbol for and, which means both. They have both of those. Okay? So this is the formula we can use. Now, how many own cars? 88, right? How many own trucks? 59 minus X, that's what I need to find. Okay, also we know the total number of survey people, residents, are 125, and we also know that 21 have no cars or no trucks. So if 125 is the area averaging inside the box, 21 is outside. This is outside 21. So actually, car or truck is gonna be this one here, right? So can you find how many have car or truck? It's gonna be 125 minus 21. From the total number, when I subtract 21, the people who have no cars, no trucks, it's gonna give me how many of them own something, right? Make sense?
Yes.
So from this equation, we can find what is X and we can find the common area. Okay, so let's solve it. It's like solving simple linear equation. So we're gonna do 125 minus 21. What is that?
104.
Okay. So I have 104 in this side. Equals, what is 88 plus 59? 147, right? Minus X. And then you can just solve it. You can move the X over and you can move 104 over. And it's gonna give you what is X, right? Or you can subtract 147, divide by -1, just simple equation. So I'm just gonna add X in both sides. So X is gonna go to the left side and I'm gonna subtract 104. And I'm gonna get X equals, what you get? 40, 43, right? Okay, 43. So 43 are the people who own both car and truck. Or let's just use letters. Car and truck, which means both, right? That's the common area here. So X is 43. So if X is 43, can you find how many on only car area here?
Yes.
So what is it?
43, 88 minus 43.
That's right. It's going to be 88 minus 43 is going to be 45.
45.
Okay. Also, can you find how many on only truck? How are you going to find how many on only truck?
You're going to subtract 59 from 43.
59 minus 43. That's right. So that give me what? 16, right? So that's it, what you have. We found everything we need. So this 43, I'm just gonna highlight the answers. So 43 on both car and truck. Only car is 45 people on only car, and only truck is only 16. Okay, everybody understand that? Any questions? Okay, and then we have one more, actually two more. We have to find the following sets of infinite or finite. Explain. The set of all meals eaten by all humans since they are human beings. Can you count them? Some people eat 5 times a day. Some people eat, I don't know. And we don't know how many people, so since they're human beings, right? So obviously, what is this?
This is finite.
No, it's infinite, infinity. You cannot count, infinite. Okay? Finite is if you can count them. Okay? Infinite, think about infinity symbol, continue forever. You can count them. Okay?
Right.
So here it's infinite. Got it?
Right.
Now, the next example, you have other following sets, infinite or finite. So we have the set of prime numbers divisible by 6. You know the prime numbers are infinite, but divisible by 6. Let's see. So here we're going to find the set of prime numbers. Which are the prime numbers? The numbers divisible by 1 and itself, right? So what are they? 2, 3, 5, what else? 7, 11, and so on, right? These are the prime numbers. The number divisible by 6, which are the numbers divisible by 6? 6, 12, 18, and so on, right? Okay, so here they said, so these are the prime numbers, these are divisible by 6. So they're asking which number is prime and also divisible by 6.
6.
Is 6 prime number?
No, wait, that's not.
So this is what you need to do. You need to find nth divisible by 6. So is there a number prime which is divisible by 6? No, right?
No.
No. So a prime number divisible by 6 doesn't exist. So that means the answer is empty set. Okay? So the answer is empty set. That means there is no prime number divisible by 6. It's empty set. Now, is it finite or infinite? Finite or infinite?
Finite.
Yes, it's a finite set. Because the cardinality of finite set is what? Of empty set? I'm sorry. Cardinality of empty set is what?
1.
0.
0.
There are no elements in the empty set.
Right.
Okay? So that's your answer here. The answer is empty set and it's a finite set. Okay? Any questions on this one? Okay, so that concludes the solution of the practice quiz 1.